reactants.
If you look at the first question, the speed of light is given, c is given, which is 3 into 10 power 17 nanometer per second. So they are asking, frequency is also given, nu is given, 6 into 10 power 15. Second inverse, they are asking lambda. So lambda is equal to c by nu. So 3 into 10 power 17 into 10 power minus 9. Acha, wavelength in nanometers only they are asking. So no need of 10 power minus 9. By 6 into 10 power 15. Then your answer will be 50 nanometers. Now the second question. N is equal to 3. L is equal to 1. It indicates the 3p sublevel. 3p sublevel. This 3p sublevel has how many m values? So m is equal to 2l plus 1. 2 into 1 plus 1. 3 values. So what are those 3 values? Minus 1, 0, plus 1. 3 values represent 3 orbitals. What is this 3 values represent? 3 orbitals. 1 orbital with the minus 1 value, 0 value, 1 orbital with plus 1 value. Actually, these are px, py, pz. But which value corresponds to which p orbital, we don't know. Generally, convention, pz is given 0. It is px. This is py. Now they are asking, what is the maximum number of electrons? So maximum number of electrons in any orbital is only 2. That is, yesterday we discussed Pauli's exclusion principle. So the answer is, this px orbital can accommodate or can have a maximum of 2 electrons. Now the third question. The activation energy for the reaction, if the rate it doubles. So actually, this Arrhenius equation you have to use here. Arrhenius equation. So temperature is rising from 20 to 35. So log K2 by K1 is equal to EA by 2.303 R into T1 minus T2 by T1 into T2. This is the formula. On here the mentioned is rate levels when the temperature is raised. So actually this is R1 by R2 is equal to K1 by K2. So this value is already given. Rate is doubling, though it becomes log 2 is equal to EA value is given already. Now we have to find out EA value by 2.303 into R value. They are already given 8.314. Into T1 minus T2, 293 minus 308 by 293 into 308. You know, log 2 is equal to 0.3010 is equal to EA by into this value becomes equal to, I already calculated, 34.7 kilojoule per mole.
Adding
34.7. Next question. Direct substitution in the Arrhenius equation. For the next question, it is hydrogen electrode where the reduction occurs into H2 gas. So E is equal to E reduction potential is equal to E naught minus 0.059 by N log products concentration by reactant concentration.
this.
So E naught is 0.059 by N is 2 electrons into log H2 concentration, product is H2. Gas concentration you can express in atmospheres. They have given 1 atmosphere. By reactant concentration, H plus ion concentration whole square. because the coefficient is 2. So this value, H plus ion concentration, they have given pH is equal to 10. Means H plus is equal to 10 power minus 10. So this value 10 power minus 10 whole square. So minus 0.059 by 2 into log 10 power 20. This 10 power 20 you can write as minus 0.059 by 2, 20 into log 10. These two you can cancel this in 10 times. You know log 10 is equal to 1.4 zeros. So this 10 into 0.059 so minus 0.59. This is reduction potential. They asked E oxidation potential. Oxidation potential will have opposite side. So that's why the answer is plus 0.59. Once again go through. pH is equal to 10. Means H plus concentration is 10 power minus 10.
Correct.
The reduction reaction is this. Addition of electrons is reduction. This is n value, 2 electrons. This is Nernst equation. Log products by reactants. Product is H2, that is 1 atmosphere. Reactant is H plus. H plus concentration is 10 power minus 10. But the coefficient before H plus is 2H plus, that's why square. So this become 10 power 20. 10 power 20 you can write 20 into log 10. That simplification you are getting minus 0.59. That is reduction potential we calculated. Next question.
Words. No.
These are the graphs, you know. Energy versus progress of reaction. In this graph, this is one graph. This is the second graph. Energy versus progress. Progress of reaction. We also mention with a other name. Reaction coordinate. So this you can also say, this is one more diagram. Let us say A plus B gives C plus D. Now this A plus B, they can't react themselves. They must acquire some extra energy to reach the top of the energy barrier. This top of the energy barrier, this energy is called a threshold energy. The energy corresponding to the top of the energy barrier is called threshold energy. Already A and B are having this much energy, but that energy is not sufficient to convert into products. So when AB has to convert into products, they must cross a hurdle. The top is the hurdle. Once they cross, they can transform into products. That hurdle or the energy related to the top is called threshold energy. The extra energy they are acquiring is called energy of activation, EA. Okay? But that is not sufficient for them to react. So they must acquire some more extra energy to reach that threshold energy. The extra energy they are acquiring is called activation energy or energy of activation. Now the difference between the energy of reactants and products is called delta H. Heat of the reaction. Here reactants are in high energy state, products are in low energy state. That's why delta H is negative. This is an exothermic reaction. This is the energy profile diagram for exothermic reaction. See the other graph. Here also A plus B, C plus D. You follow this graph also. A plus B are acquiring this extra energy. What is this called? Activation energy. And the energy of C plus D is greater than A plus B. So when compared to reactants, products are in high energy. So this is delta H. This is positive. It is endothermic reaction. This is energy profile diagram for endothermic reaction. This is energy profile diagram for exothermic reaction. Now, suppose if it is a reversible reaction, this is the activation energy of backward reaction, EAB. This is EAF. So what is this called? EAB, activation energy of means C plus D. If they want to convert into A plus B, then they should cross this energy barrier. A plus B to convert into C plus D, this energy barrier. Anyhow, the energy barrier is same when A plus B has to convert into C plus D or C plus D is converted into A plus B. They must cross the same energy barrier. But what is the activation energy of reactants? The energy possessed by them and the energy they must extra acquire. This is called activation energy of forward reaction. What is the activation energy of backward reaction? The energy possessed by the reactants, this is the energy, and the energy, extra energy they must acquire. So this entire height. Now in this question, they have given EAB is equal to EAF, correct? They have given this. This is EAF. This is also EAB. When both are equal, when the reactants A plus B are having same energy as C plus D, then only the EAB and EAF become same. This is EAB. EAB I am writing the outside. When both reactants and products, when reactants and products are having same energy, then delta H is equal to 0. So that is the answer. Next question. At 25 degrees molar conductivities, they have given some values. Degree of ionization. So degree of ionization alpha is equal to lambda molar concentration by lambda molar concentration at infinite dilution. So lambda molar concentration is given as 9.54. At infinite dilution they have given it as 258. 238. They are asking percentage alpha is equal to 9.54 by 238 into 100. So that will be the answer, 4.008%. So next question, they have given energy of the electron E minus 2.178 into 10 power 18, 10 power minus 18 joules into Z square by N square. Already we have given E is equal to minus 13.6 into Z square by N square. Electron volt per atom we have given. We have also given into Z square by N square. Kilocalorie per mole. These are all energy expressions in different units. This is in joules, this is in electron volts, this is in kilocalories. So what is the energy expression in ergs? Ergs 10 power minus 11. 2.178 erg into Z square by N square. This is erg per atom. Erg atom inverse. This is joule atom inverse. So different units for the energy expression for the electron of hydrogen atom or any other single electron species. These expressions are useful for not only for hydrogen atom, for any single electron species like helium plus, like lithium 2 plus. Okay. Now after giving this expression, they have given four statements. Negative sign in equation simply means that energy of electron bound to the nucleus is lower than it would be the electrons were at infinite distance from the nucleus. So this is atom. So electron and the nucleus, since they are bound by attractive force, electron energy will always have negative sign.
Yes, please.
Energy of electron has always negative sign. Now let us assume that the electron is completely removed from the atom. Now it is isolated electron. Isolated electron. The electron which is isolated completely, its energy is 0. Energy of isolated electron is 0. So when zero energy electron, when it is totally free, when it comes to the attractive force of the nucleus and bound by the nucleus, its energy decreases from 0 to negative side. Thus, an electron will always have energy with negative sign. So, first option is correct. Larger the value of n, larger is the orbit radius. Because Rn is equal to 0.529 into n square by z. So, Rn is directly proportional to n square. So, second option is also correct. Equation can be used to calculate change in energy when the electron changes the orbit. So, this equation minus 13.6 into n square, if it is n1 square, E1, E2, n2 square, 2Ag plus Ag is also given. It is 0.34 volts. When you know two E0 values, E0 means standard reduction potential. What is E0? Standard reduction potential, SRP. E0 is also called SRP. Standard reduction potential. Write a point. Higher the negative value of SRP, higher the negative value of SRP, greater is its tendency Greater is its tendency to undergo oxidation.
Just get it.
That is, greater is the tendency to act as anode. To act as anode. So in this it will act as anode.
So, son,
Higher the positive value of SRP, greater is the tendency to undergo reduction and acts as cathode. So by seeing these values, you can say which is anode, which is cathode. Now they are asking E cell is equal to E cathode, E naught cathode minus E naught anode. E naught cathode is 0.34 minus of my 0.76. So that is the answer. I think it is 1.1 volts. Next question.
Sir. What do I say? Check.
Now in the class I discussed this point. Molarity is equal to weight by gram molecular weight into V in ml by 1000. Suppose if I want W, molarity into gram molecular weight into 1000 by V in ml.
But
Now they ask us to calculate weight of solute of which concentration? 70% concentration. Let us say weight of solute is X of 70% concentration is equal to molarity is given how much? 2 molar. What is gram molecular weight of HNO3? 63 into 1000 by 250 ml. So this is 0.7x is equal to, this we cancel 4 times. So this is the, sorry, this is wrong. 1000 by V in ml.
Yes.
1000 by V in ml, then it becomes reverse. V in ml by 1000, then it is 250 by 1000. 4 times, this 2 times, 231.5 times, X is equal to 31.5 by 0.7. So that will be the answer. So you will get 45. Actually, next 2 questions are, or next 55th question you write deleted. Solid state chapter is deleted. And 57 also deleted. Now 56 we take up. In 56, maximum deviation from ideal gas is expected from. Write 2-3 points. An ideal gas is one which should not have an ideal gas is one which should not have any intermolecular forces of attractive or repulsive forces.
Okay.
An ideal gas is one in which have no intermolecular forces of attraction or repulsion. Next point. The gas which have more intermolecular forces of attraction or repulsions the gas which have more intermolecular forces of attractions or repulsions will deviate more from ideal behavior. Next point. Gases which are easily liquefiable. Gases which are easily liquefiable means more intermolecular forces will deviate more from ideal nature. Next point. Gases like hydrogen and helium, gases like H2 and He are difficult to liquefy. Hence they are more close to ideal nature. Gases like, next point, gases like ammonia and HCl are easily liquefiable. Hence they deviate more from ideal nature. See how many points I mentioned. So almost in states of matter, we discuss all these points under the heading of ideal gas and deviation from ideal behavior. So what are ideal gases? Gases in which the molecules do not have any attractive forces or repulsive forces are said to be ideal. But there is no ideal gas in the nature. In the universe, there is no ideal gas. It is purely hypothetical. So suppose if they ask the question, which is an ideal gas? Suppose if they ask. Option A, B, C, they give hydrogen, helium, ammonia. Option 4, no ideal gas. So the answer is option 4. There is no ideal gas. Because when gases are compressed, apply pressure and compress, the molecules come very close to each other. When molecules come very close to each other, they will be attracting with each other. When they are attracting with each other, automatically the attractive forces dominate. Even they come still closer and they become liquid. That is called liquefaction. So what are the two ideal conditions for liquefaction? High pressure and low temperature. That also mentioned. Two conditions favorable for liquefaction are high pressures and low temperatures. Are high pressures and low temperatures. Okay, now in this context, there is ammonia gas. Ammonia can be easily liquefiable. It is used as a refrigerant for ice plants, cold storages. What is the refrigerant? Ammonia liquid. So ammonia is easily liquefiable gas. So when it is going to become easily liquid, means the molecules have more attractive forces. When they have more attractive forces, they deviate from more from ideal nature. Which gas is said to be ideal? There should be no attractive forces. But ammonia molecules have more attractive forces. How do you know that it has more attractive forces? Will it say, hello, that I have more attractive forces to you? No. It is an experimental observation that when ammonia gas is compressed, it readily converts into liquid state. So whenever a gas is easily being converted into liquid state, we call it as easily liquefiable gas. Easily liquefiable gases deviate more from ideal nature. There are two gases which are difficult to liquefy. They are hydrogen and helium. That's why their behavior is close to ideal nature. That doesn't mean that they are ideal gases. Because helium can also be liquefied. The boiling point of liquid helium is 3 Kelvin. 3 Kelvin means how much temperature? Centigrade scale. Minus 270 degrees centigrade. At that temperature, helium exists in liquid state. But it is a very low temperature, minus 270. So helium can also be liquefied. And liquid helium is used as coolant for cryoscopic rocket engines. What is meant by cryoscopy? You have studied depression of freezing point in your solutions chapter of your 12th class, where you have colligative properties like elevation of boiling point, depression of freezing point, osmotic pressure, and lowering of vapor pressure. In depression of freezing point, you also study an equation, delta TF is equal to Kf into m. M is small m, molality. What is depression freezing point? Delta TF is equal to what? A constant called Kf into molality. What is that Kf called? molar cryoscopic constant. There you have just listen the word cryoscopy. Cryoscopy is a low temperature technique. Very low temperature techniques are called cryoscopic techniques.
Right.
That's why nowadays some doctors are using cryoscopic techniques to remove the belly fat or the body where more fat is accumulated. They apply very low temperatures. The fat gets solidified. The solid fat is removed easily by suction. But that technique, cryoscopic surgeries, so far FDA has not approved. FDA means Food and Drug Administration of the United States. It is a stringent medical body, and it is any drug or medicine or a technique has to come into the market. It should have FDA approval. But there are many techniques in many countries not approved by FDA they are using. Sometimes they are dangerous because FDA scan and screen every point. If you discover any medicine, FDA approval minimum takes 10 to 15 years to come into the market. 10 to 15 years. Even it may take more than that also. So that much a stringent regulatory authority, all biomedical instruments, all medicines, pharma related, every aspect is governed by FDA. So you should not go for cryoscopic surgeries, and you should not also go for bariatric surgeries. People are also going for bariatric surgery, where your intestine is cut into a small part and put a band, gastric band. So that what happens, even if you eat little, stomach is full, you can't eat more. People with too much obesity, like our Akash Ambani, recently got married. Maybe he is having some physical, medical problems, we don't know. So he is too much obese personality. But bariatric surgery, Ambanis can go, but many people who got bariatric surgeries, they mysteriously died. Some cinema actors and all these. That's why it is also not approved by FDA. What is FDA? Food and Drug Administration of the United States. A watchdog. It is a watchdog. Next question. Dipole, induced dipole. Any polar molecule develops both positive and negative charges called poles, and is called a dipole. How polar molecules, what is polarity? Due to unequal sharing of electron pair, unequal sharing of electron pair, between the bonded atoms, polarity arises.
When it is in my working.
And this is only possible. So possible only in heteroatomic molecules. Heteroatomic molecules. If you take two similar atoms, they are called homoatomic molecules.
But
What these? Homoatomic molecules. No polarity. In homoatomic molecules, they are called non-polar molecules. So H2, F2, O2, N2,
how about you?
N2 share 3 pairs of electrons between them. When 3 pairs are shared, you will get a triple bond. When 2 pairs are shared, you will get a double bond. So now, all those molecules I mentioned, what molecules they are? Non-polar molecules. They contain same atoms. They are called homoatomic molecules. Now the question, a small fundamental question I ask to any one of you doctors, you can answer this. What are the attractive forces between non-polar molecules? That intermolecular forces, what is the name of that? Dr. 1, what are the attractive forces between the molecules of non-polar in nature, like H2 and H2, O2 and O2, N2 and N2? No, sit down and answer.
And what it was?
They are covalent molecules. What are the type of attractive forces between them?
Didn't you still come from the last first?
Yes, she got final. Between non-polar molecules, the type of attractive forces or intermolecular forces are called van der Waals forces or London dispersion forces. You also mentioned that point. The intermolecular forces in non-polar molecules, the intermolecular forces in non-polar molecules, the intermolecular forces in non-polar molecules are weak van der Waals forces
I know.
or weak van der Waals forces
What?
or the other name is
Bye.
London dispersion forces. And these forces, van der Waals or London dispersion forces, London dispersion forces which are already weak
The other person.
are directly proportional to. Yes, anyone? One more point I want to cover. London dispersion forces or van der Waals forces are directly proportional to. The answer, molecular size. Molecular size
Listen.
or surface area of the molecule.
Psychotic. Did that anger?
What's wrong with you? Did you?
Now, you all know C4H10 has two chain isomers. C4H10 is butane.
Keep it right.
It has N-butane, CH3, CH2, CH2, CH.
What's that on?
Normal butane or N-butane. The second one is isobutane.
Thanks. I can't believe it.
Figure out this better.
What is the IUPAC name of isobutane? 2-methyl propane.
Okay.
One is a straight chain alkane, the other is a branched isomer. They are called chain isomers because they differ in the nature of chain. One is a straight chain. Suppose if you hold this and that, two corners and stretch, it becomes straight. This is branched. By stretching, it won't become straight. Middle carbon branching is there. Now they ask the boiling point. Let us say this is 1, this is 2. Boiling point of 1 is greater than boiling point of 2. Why? I can give assertion reasoning type question. Assertion, boiling point of N-butane is greater than boiling point of isobutane. That is assertion. Reason, N-butane has a straight chain with more surface area and more van der Waals forces of attraction. If I give this is the reason, then your answer is option number 1. Both 1 and 2 are true, and 2 correctly explains assertion. So what is my question? Why N-butane has higher boiling point than isobutane? Because it has straight chain with more surface area. Because of larger surface area
GP1.
and more van der Waals or London dispersion forces. Due to more van der Waals or London dispersion forces. So here I have covered what are non-polar molecules. When the electron pair is equally shared between them. So in all these molecules, electron pair is equally shared. Why they are non-polar? The electron pair is equally shared. They are non-polar molecules. Now, look at these molecules, HF, between hydrogen and fluorine.
And why is the feeling conscious?
What's doing it?
Yep, sorry.
I was
The electron pair is more close to fluorine. Or look at HCl.
Maybe then. What is CT?
Here also, the electron pair is away from the hydrogen, but more close to chlorine. Like HBr, HI, water. In water, the electron pairs are more close to oxygen than hydrogens.
but
So these are all called heteroatomic molecules.
That's all that.
This is ammonia.
can show this back.
So ammonia, water again I draw. So in all these, what happens? The electron pairs are unequally shared. The electron pair will more close to more electronegative atom.
What is that noise?
When electron pair is more close to a particular atom, that atom will acquire a partial negative charge. The other atom will acquire partial positive charge. A negative pole and a positive pole are created. That's why the molecule is called a polar molecule, or it is called a dipole. So here in Cl carries negative, H carries positive. In oxygen, O carries negative, hydrogens carry positive charges. In ammonia, N carries negative, hydrogens carry positive charges. So write a point.
Keep that.
In polar molecules, the type of intermolecular forces in polar molecules, the type of intermolecular forces of attraction, the type of intermolecular forces of attraction are strong dipole attractions, or strong dipole attractions.
What? Yeah. I registered it. This road block. It's true.
So two dipoles attract with each other. I'll show like this. Let us say this is HF. This is negative pole, this is positive pole. Let us say this is another HF. This is negative pole, this is positive pole. This positive negative pole attract with each other. So this entire dipole is attracted by this entire dipole. Positive negative attractions, negative positive attractions. What are these attractions are called? Dipole attractions. These are relatively strong. Suppose I give, or I just frame a question like this. Are you ready to listen the question? Yes. The boiling points of polar molecules are always greater than the non-polar molecules. Suppose this is assertion. What is my assertion? The boiling points of polar molecules are always greater than non-polar molecules. Now my reason. Polar molecules have stronger dipole-dipole attractions and non-polar molecules have weak van der Waals forces of attraction. If I give these two statements, so what is your answer? Both 1 and 2 are true. And second statement correctly explains the first statement. Why the boiling points of polar molecules are always greater than non-polar molecules? Because polar molecules always have stronger dipole-dipole attractions, whereas non-polar molecules have weak van der Waals forces of attractions. So this much story is there for that particular question. Now in that particular question, they have given some combinations. In which combination there is induced dipole-dipole attractions. So in that particular scenario, you should have one molecule as a polar molecule, the other should be non-polar. Then the polar will induce the opposite charges in the non-polar. That is, if I consider this option HCl and helium atom. Helium atom is non-polar, no charges. But this is polar, it has a dipole. What this polar will do? It will disturb the helium atom. The positive charge present on the hydrogen will pull this electron cloud of helium towards itself. The positive charge of hydrogen in HCl molecule will attract the negative electron cloud surrounding the helium nucleus. So that's why what happens in helium, though it is initially symmetrically distributed, the electron cloud is symmetrically distributed around the nucleus. Because hydrogen is pulling it, obviously its shape distorts. It will become like this. Negative charge will come to this side and positive to this side, because H plus is pulling the electron cloud. So the negative charge of helium comes towards H plus. Though it is no charges initially, because of the pull, the entire cloud is moving towards one direction. When the electron cloud shifts or drifts in this direction, this part will have negative, the opposite side will have positive. So this is called induced dipole-dipole attractions. So what is the condition for induced dipole-dipole attractions? One should have, combination should have one polar molecule, the other should have non-polar molecule. Now look at the options. H2O and alcohol, both are polar. First option, both are polar. Second option, both are non-polar. Second option, both are non-polar. What is second option? Chlorine and CCl4. Yes. So why CCl4 is non-polar?
Can because that's the one vitamins that's and
Because
the vitamins cancel each other out because they're in both directed. I mean all four are there.
correct. She is right.
Okay.
CCl4, why it is non-polar?
See?
Though 4 chlorines are there,
Basically,
it is a tetrahedral molecule. Don't worry, your pen will be given back.
the vitamins.
This is a tetrahedral molecule, CCl4. Here one chlorine, here one chlorine. At each corner one chlorine. Center at my fingers carbon is there.
Look out.
Now this chlorine is pulling this electron towards itself. Each chlorine is pulling the electron pair towards itself because chlorine is more electronegative than carbon. So this vector acts in the upward direction. The resultant of these 3 vectors will act in the downward direction. The resultant of these 3 vectors will act downward direction. This vector will act in the upward direction. Both these will cancel. So the resultant dipole moment is 0. Whenever mu dipole moment is 0, it is non-polar. So write that point. Hope this is yours. This is. So write a point. CCl4 is non-polar because CCl4 is non-polar though it contains 4 polar covalent bonds. Though it contains 4 polar covalent bonds because
Sleeping.
dipole moment depends on
Like this.
both the magnitude of charge and direction. Both the magnitude of charge and direction means it is a vector quantity. Means it is a vector quantity.
Dive. That means.
So write this.
Yeah.
So this vector will act in this direction. So these are the total 4 vectors.
Exactly.
So the resultant of these 3 vectors will act in the downward direction. This act in the upward direction. Write the same point. The vector which is acting in the upward direction, the vector which is acting in the upward direction is cancelled by
Yeah, that's it.
The resultant vector of the 3 CCl bonds. Resultant CCl bonds. Hence net mu is equal to 0. Hence it is non-polar. So the option chlorine and CCl4 both are non-polar. That won't work out. First option is both are polar. That won't work out. Third option you take HCl and helium. HCl is polar. Helium is non-polar. So it will pull this electron cloud. When hydrogen pull this electron cloud, it will acquire negative charge and positive charge. So temporarily helium gets, it's not a permanent change. If HCl is not there, it will retreat back. It will become normal helium. When HCl is there, due to H plus pulling the electron cloud is symmetry is lost. It becomes protruded towards this side, it will get minus. The opposite side you will get plus. So that is the answer for induced dipole-dipole. If you go to the last option, silicon tetrafluoride, like CCl4, SiF4, is also mu is equal to 0. Why its mu is equal to 0? Quick, the vector, the upward vector and the resultant of the downward will cancel with each other. Net mu is equal to 0 means it is non-polar. Now the next question. Actually this we have already worked out. Magnetic momentum mu is equal to root of n into n plus 2 Bohr magnetons. If n is equal to 1, then only we will get root of 1 into 1 plus 2. That is called root 3. 1.73 Bohr magnetons. So among the given options A, B, C, D, one should contain n is equal to 1. What is n here? Number of unpaired electrons. What is n here? Number of unpaired electrons. So if you take the first option, CuNH3 4 times 2 plus, copper atomic number 29, 3D10 4s1. In Cu2 plus, it becomes 3D9 4s0. It contains one unpaired electron. So the answer is first option. In second option, tetracyano, nickelate 2. Write n is equal to 2. Nickel is in plus 2 state. In third option, titanium tetrachloride. Titanium atomic number is 22. In titanium plus 4 with 18 electrons, argon configuration, n is equal to 0. In the last option, Cl6 4 minus, n is equal to 2 again. Next question. Next question is a direct question. Roasting of any sulfide ore give sulfur dioxide. SO2 has three characteristic recognizing tests. It has burning sulfur smell. Burning sulfur smell. It turns lime water milky.
Describe.
Like carbon dioxide. It turns acidified dichromate, acidified K2Cr2O7, which is orange color, into green due to chromic sulfate. So the answer is SO2.
That is good.
Next question. Strongest acid among the following. Strength of acid is directly proportional to stability of the anion or conjugate base.
That one.
Strength of the acid. Question number 61. Strength of the acid is directly proportional to stability of the conjugate base or the anion.
Six.
Now if I write HClO4 gives H plus or H plus ClO4 minus. The ClO4 minus is called perchlorate ion. Perchlorate ion. Now the negative charge on the oxygen can be distributed among 4 oxygens by means of resonance. The more the resonance structures a particular ion or a molecule has, the more the stability. So here I am going to write the resonance structures of ClO4 minus perchlorate ion.
So what? Listen.
If this negative charge shifts like this, the other pi bond shifts. You will get a resonating structure like this. This O become minus. When this negative charge again shifts back, this pi bond shifts. Now this oxygen will get negative charge. And again, when this negative charge shifts, this pi bond shifts. So if you observe all these resonating structures, so perchlorate ion is more stable. Why it is more stable? Due to more number of resonance structures. Okay, when it is more stable, it says to the parent acid HClO4, which is called perchloric acid. Now these anions tell their father You don't worry, even if you lose H plus, we are very happy. We are stabilized by resonance. That's why the parent acid can lose H plus very easily. The one which readily loses H plus is a stronger acid. Why perchloric acid readily loses H plus? Because the anion formed from it is resonance stabilized. That's why it is the strongest acid. Now, which of the following is paramagnetic? 62nd question. So the answer is O2 minus, which is called superoxide ion. Superoxide ion, total number of electrons. Total number of electrons is equal to 17, means odd number. 16 will be even number, one extra electron. Whenever odd number of electrons are there, it is paramagnetic. You also mention superoxides are formed by, next point, superoxides are formed by the heavier metals of first and second groups. Superoxides are formed by the heavy metals of potassium superoxide. Rubidium superoxide, cesium oxide. Similarly, second group, beryllium, magnesium, calcium, strontium. This is barium superoxide. So the heavier elements of first group, second group, strontium superoxide. Only these 5. In this, you have one more application which is asked in the NEET examination. The one which is used in submarines. The answer is KO2. Write that point. KO2 is used in submarines. Very large. So it has the mechanism, so many pump sets which fill water into the ducts. When so much of water is filled into the ducts, because of the weight it submerges, it goes deeper and deeper into water. And if suppose you want to reach the surface, then water is evacuated from the ducts. This is the basic mechanism of submarine. Totally closed, pressurized cabin. So the crew will be taking respiration, oxygen and release carbon dioxide. So how to remove that carbon dioxide and supply fresh oxygen to the crew members? There are many shelves on the walls of the submarine. On each shelf are rakes. They put KO2. So large KO2 is kept here and there. What that KO2 will do? It will absorb CO2 and gets converted into K2CO3 and release oxygen. Well, I have seen practically the submarine. We have a submarine museum in Andhra Pradesh at Vizag beach. A Russian built submarine which was used long back by the Indian Army. Now it is decommissioned from the Army. That's why it is kept for public. What will be the mechanism of submarine? How is it inside? So everybody will purchase a small ticket and go inside, and the people will explain. So the technology used by Russians, it is 1940s submarine, World War II type submarine. Even the technology is extraordinary. Now we have nuclear powered submarines now. Because normal fuels cannot pull it. So the power should be nuclear power. We have nuclear powered aircraft carrier leased by our country from Russia. It is called Admiral Gorshkov in Russia. Its name. But when it entered Indian waters, for 100 years we took it for lease. A nuclear powered aircraft carrier. It carries the aircrafts. So when it entered into Indian waters, the so-called Admiral Gorshkov, it is named as INS Vikramaditya. Now it is in India, in some of the ports in south. So defense analysts say that it is a game changer. Once it reached into Indian waters, all these neighboring countries are alerted. The size of the ship will be like a 5-floored building, and the roof of the ship is equal to the size of a football ground. Means you can imagine how big it is. That's why many aircrafts are stationed on it. They directly take off and land on the aircraft. That's why it is called aircraft carrier. It is also powered by nuclear energy, nuclear fission. Because normal diesel, petrol, they can't, normal combustion engines cannot push or pull it. The power should be very high. That's why we use nuclear power to move the ship here and there. So that is the technology Russians were using. Okay, now superoxides are paramagnetic because of unpaired electrons. We already discussed paramagnetism in our atomic structure lesson. Paramagnetism, diamagnetism, ferromagnetism, these three are already discussed. Next question. This is a memory recall type question actually. Now the graphite structure, which is a layer lattice structure with hexagonal ring systems, fused ring systems in graphite.
Let's see.
I can write one more ring like this, or one more layer.
On the side, please. So good.
This is another layer of graphite. Between two layers of graphite, the distance is 3.34 angstroms. And in graphite, there is one free electron on each carbon. and the carbon atoms are sp2 hybridized. It is a trigonal planar. Each carbon is trigonal planar. These free electrons in graphite move through the entire lattice. Free electrons move. That's why graphite is a conductor of electricity. Why graphite conducts electricity? Due to free electrons. Between one layer and other layer, they are not attached layers, there is a minute gap. How much between the two layers the gap? 3.34 angstroms units. That's why when you apply pressure on graphite, one layer will slide over the other layer. Sliding or slippery nature of graphite is due to weak van der Waals forces. One layer will slide over the other layer. Now what makes and what use we make utilize graphite in this particular property? If you touch your pencil nib, it is slippery or sliding. If you touch your pencil nib, it is graphite only. Your ordinary pencil, HB pencil, is graphite, which we call lead pencil. What is the percentage of lead in lead pencil? What is the percentage of lead in lead pencil? The answer is 0. Then why it is called lead pencil? The answer is lead marks on the paper. Graphite also marks on the paper. Because of this marking nature, it is resembled to the lead. We call lead pencil. Actually, in the lead pencil, it is a mixture of clay plus graphite. So what is your lead pencil contains? Clay plus graphite. Why to add clay? To make harder. The nib harder. If it is pure graphite, it is too soft, too slippery, too sliding in nature. So this property we use as a lubricating material. Graphite is a lubricating material for any heavy engines. If you want to reduce the friction among the engine parts, we add solid graphite powder. These all are in your NEET syllabus. So graphite is a good conductor of electricity due to the presence of free electrons. Graphite has a layer lattice structure. Graphite carbon atoms are sp2 hybridized with 120 degrees bond angle. The sliding or slippery nature of graphite is due to movement of one layer over the other layer. Now, boron nitride have the same structure with 3 boron atoms and 3 nitrogen atoms. Instead of carbons, you have to write borons and 3 nitrogens. Here all are carbons, but in boron nitride, boron, nitrogen, boron, nitrogen, boron, nitrogen. So the structure of Bn and C graphite both have layer lattice structure. Layer lattice structure.
Okay. Okay. You don't forget.
So this is the, how do you know this? By X-ray diffraction. X-ray diffraction is an experimental tool to know the internal structure of solids. So the internal structure of solids is known with the help of X-ray diffraction. Who is the father of this X-ray diffraction? Professor William Bragg. We have studied Bragg's equation also. N lambda is equal to 2d sine theta. Of course, that chapter is deleted. So who is the father of X-ray diffraction? William Bragg. I have to tell an important information about William Bragg. Actually, William Bragg's life ambition was to become a gardener. But he settled as a physics professor in Australia. But later he migrated to London. And though he is working in one of the famous universities of London, Cambridge or Oxford, he received Nobel Prize in physics for his X-ray diffraction. After receiving Nobel Prize, working as a professor of physics, every day he used to worry a lot that why God has given this offer to me. I should become a gardener, to work in garden with green plants. So every day he is looking for advertisements, any part-time gardening post. Luckily one day he saw a small ad that one person required a part-time gardener for his garden. So he immediately applied, and he did not reveal his identity, appeared for the interview. So he asked about plants, the fertilizers or pesticides, how to use and all this. He is well versed with all those. He got through the interview and he is selected as a gardener. So every day morning, some morning 6 to 10 like that, he is working in the garden and he is extremely satisfied now. After 10 he is going to his lab, X-ray lab in the university. So a Nobel laureate working in a reputed university, part-time his job was gardening job. One day some friends and relations, they visited that particular house and the landlord wanted to show them the garden. And all went into the garden where he is working. So immediately the other people who were visiting, they recognized him. And immediately they asked him, the landlord, are you mad or foolish? Who is working in your garden? You are telling that he is a gardener. He is not a gardener. He is a reputed professor of physics and a Nobel laureate. And all of them immediately went and seek apologies from him. So he said, no, don't tell any apologies. I am grateful you have provided me this part-time job. Let not to reveal to others. I am very much satisfied because it's my life ambition to become a gardener. At least partly I am fulfilling that ambition. So some people, they have certain ambitions and visions. Though they enter into other line, some may they completely revert and come to their original line, which they are interested. And some people partially fulfill their obligations. Like Tito, not Marshal Tito of Yugoslavia, one American student He is having life ambition to go into space as an astronaut. The precondition for astronaut, he has to enter into American Air Force and become a pilot. So he fulfilled that. He prepared well and finally got into American Air Force. He is serving in American Air Force as a pilot for fighter aircrafts. Meanwhile, the NASA will announce now and then any new aspirants to go into space from American Air Force. He applied immediately because he joined American Air Force because of this reason only. He applied. But selection for astronaut is very difficult. There should be well balance of mind, physical, mental, fitness, many things they see. So after thorough screening, he was rejected to go into space. Then he became very angry. Without going into space, there is no meaning for this job. Immediately resigned. Resigned from American Air Force and started a hotel. And he is happy now. At least no space, no pilot. He is doing a business, earning money. Finally, the Russian space program has a money crunch. The space program is having short of funds because Russia is divided into republics. So immediately Russian aerospace industry, which is called Raw Cosmos, they announced a ticket, space tourism, they announced. If anybody wants to go into space, we are going to sell the ticket. Our rocket will take him to space. And the ticket is too costly because space program itself is costly. So luckily he earned huge money by hotel business. He immediately purchased the first ticket. The first space tourist to space by Russian rocket is this Tito, an American ex-fighter pilot of American Air Force. So Americans worried a lot because he may reveal some secrets. He served in the American Air Force. So they objected, Russia, no, don't take him. They said, no, we don't have any discrimination. Those who pay the ticket money, we will send. Immediately he was called the Russian space program. They gave some training. So Russian aircraft rocket took him to the space and docked to the ISS. You know ISS is? International Space Station. So he entered into ISS, spent 10-20 days there with the fellow cosmonauts, astronauts, different country people will be there. He enjoyed the trip. And Russians have a unique mechanism bringing back the cosmonauts or astronauts to Earth. They use a space module, like a pear-shaped, egg-shaped vessel. The vessel is heat resistant and thrown with a particular velocity in a particular direction. So it follows a particular path and finally lands in a desert. So it falls in a desert, in sand, like a big fruit is falling on the earth. Then immediately the module will be opened, the persons will come out. And this technique, which appears to be very primitive, Russians, with this primitive technology, Russians have not lost a single life. Whereas the American space shuttle program suffered many casualties. So Tito back to the earth. Now he is still running his hotel business. So ask the doctor to wake. Oh, deep sleep. You are here or in space?
Yes, I don't like that. question. Yeah, the test. Just the thing. Just the. Oh,
So if you have life ambitions,
no, but
just keep them alive.
just look.
Latter part, if you want to become a cinema hero, you can become. If you want to become a politician, you can become. Or if you want to become a singer, you can become a singer. But time has to come. You have to wait. Presently, you are a student and a NEET aspirant for 2025. That we will fulfill first. Okay, next one.
Just kind of it. You can like it. Skip. But then we do it. You can wait. I bring the hot. You know the. This one. This one.
In all silicates, SiO4 4 minus,
Today.
which is SiO4 4 minus,
I have it.
tetrahedral units are present. That is the basic unit in all silicates. In orthosilicates, these separate units are present. If separate
Look here.
units,
You go through.
if separate units of SiO4 4 minus are present, the silicates are called orthosilicates.
What?
So, to. You know.
Now you have studied one orthosilicate. Sodium,
The different. Down.
aluminum,
Okay.
orthosilicate.
It's in fucking.
Yeah.
Can be.
Because 3Na plus no. Acha, NaAl, not sorry.
What do you which on the first?
Or I will write again. This 4 minus is balanced by 1 Na plus and the 3 minus is balanced by aluminum 3 plus. That's why sodium,
But
aluminum, orthosilicate. Why 1 Na, 1 Al? 1 Na carries 1 plus. 1 Al carries 3 plus. Total positive charges become 4. SiO4 carries 4 negative. Sodium, aluminum, orthosilicate,
dancing.
which is called permutate. Permutit. Where you have used permutate? For removing the hardness of water. Write that point. Sodium, aluminum, orthosilicate is called permutate, which is used for removing the hardness of water. Now the next question, 65.
I think it's up to
What?
Turkish.
Okay. Take short break, no problem.
Oh, well. So far, real stuff out. And that's what I'm going to do. There's people suffering because it is only one shot. The cross or the nice mouth. And I will get on the race that and see what we should be carrying out. It's a style. This is that decade of the guy. That's the other little. My own particularly the beings, the application of this. I want to see them and was like this again about the kids.
So I'll just save the file. I'll just save this file.
It's fun to work with them and what the national number and those insurance come up and then it's really that sort of it. Like, I've done one of the students action policies in our and when you bake the map and exactly when it's out and the people they shall none of the one sound the and just and what get what was what you and kill the right to be people know stuff with people and the people who expect to be the one so the birds come to them
So then what is that word?
I should see yeah it's that if you not on stage that means should so that's only at it and a guy can have a roof in a pretty car but then some are be roll to the number I don't feel listening so that's where the acting down trying to play into the button
What's that man?
then we got nothing got the one people some of what I say this is not that
Then how do you fix
this
So it now
fix people this
Oh, it's pretty bad.
I see
If with that, you know, that I'm asleep.
Interesting. It said that you guarantee
yeah but we say it's right there
no
eventually I think
for the fun.
improvements are not being
I see all the
I'm proud to give to this Christian dollars and then we should
This is the mistake you do.
Christian step 8.
Jeff,
The house card doesn't be so nice, but it's nothing.
there's a college so
So on this graduate time.
we don't wait. A bird, you have to move this.
65.
You're again.
Jump in with it. Little season.
65.
Get
Same way to it.
let's forget.
Which Bengali cannot be prepared. First, if you take the toluene
Got him up.
by using chromyl chloride
2 things.
in carbon disulfide, you will get benzaldehyde. This is called Itard's reaction.
Beautiful prediction.
Itard's reaction.
Stay.
Now the second one, you take benzoyl chloride, which is converted into benzaldehyde, by hydrogen, vanadium, barium sulfate.
This
This is called Rosenmann's reduction.
I need to put the lawyer.
Write a point. In Rosenmann's reduction, write a point.
Keep the what?
That's it.
The function of barium sulfate
Now, the get only keep move up.
The function of BASF
You take
is to prevent the further reduction of
listen.
the function of barium sulfate
Yeah.
in this reaction is to prevent further reduction of benzaldehyde
This one everything.
That's the topic.
into benzyl alcohol. Into benzyl alcohol. C6H5CH2OH.
It could be.
That means it acts as a catalytic poison. It acts as a catalytic poison.
It makes it.
Next. This is Gattermann's co-formylation. In the presence of ALCL,
Okay.
you will get benzaldehyde.
They
Let's take that. Let's take that one.
Gattermann co-formylation. Here also write one more very important point.
This and
This reaction is an example of EAS. This reaction is an example of EAS. What is EAS? Electrophilic aromatic
make this.
substitution. This is an example of EAS, electrophilic aromatic substitution. And the electrophile is formyl carbocation. Formyl carbocation. Now the last one. The last one. Benzoic acid.
Wait.
If you use zinc amalgam and concentrated HCl,
Then they
no action.
shoot.
Write a point. Zinc amalgam and concentrated HCl is used in Clemenson reduction. Is used in Clemenson reduction. Where aldehydes and ketones are converted into alkanes. Aldehydes and ketones are converted into alkanes. So RCHO zinc amalgam, concentrated HCl. It becomes RCH3 plus H2O. RCOR, ketone. Ketone is converted into RCH2R plus H2O. So this carbonyl group is reduced to methylene group. We also mentioned this. In Clemmensen reduction, the carbonyl group what is carbonyl group? C double bond, right? C double bond. Is reduced to CH2 group. What is the name of CH2 group? CH2 group means methylene group. Next person. Next person. This we already discussed in the class. Decomposition reactions. It liberates oxygen. They have given one more chlorate, zinc chlorate. Same gives ZnCl2 plus O2, right? 3O2. Third one, this is also given in the class. K2Cr2O7 on heating. K2Cr2O4 plus Cr2O3 plus O2. For the last one, ammonium dichromate. What is the name of this? Ammonium dichromate. Ammonium dichromate on heating gives nitrogen plus Cr2O3 plus 4H. It is used to give nitrogen. Decomposition of ammonium dichromate is a very popular experiment in the science space, where we call it as chemical volcano. Whenever ammonium dichromate is just started decomposing, it explodes and forms like a volcanic eruption. So right below that, it explodes like a chemical, it explodes like a volcano. It explodes like a volcano. And it's called chemical volcano. Next question. Diamagnetic substances should not contain any unpaired electrons. All paired electrons. So ytterbium 2 plus has 4F14 configuration, YB2 plus
That.
has 4F14 configuration, no unpaired electrons, diamagnetism. Next question. Correct order of solubility in aqueous medium. Correct order of solubility in aqueous medium. Na2S, Cu, cupric sulfide, G sulfide, these are given. This is first group sulfide. These two are sulfides of D block. Right a point. First group sulfides are more ionic in nature. First group sulfides have more ionic nature. And are more soluble in water. So the answer should start with Na2S greater than. So you got a clue now. Now, what about the remaining two? Zn 2 plus is larger than Cu2 plus. That's why it has less lattice energy. So lattice energy is inversely proportional to size of ions. So between cupric and Zn2 plus, which is larger in size, Zn2 plus. That's why it has less lattice energy. That's why it is more soluble. Finally, the CUS comes to the last. This is due to less lattice energy. This is due to more lattice energy. This is due to more ionic nature. Na2S is more ionic nature, more water soluble. Then why second position is occupied by Zns? Because Zn2 plus is larger than Cu2 plus. When the size of ion is bigger, lattice energy will be smaller. When lattice energy is smaller, the lattice easily break and become soluble. Next question. HCF2 is isostructural. Actually, first of all, any molecule is given. First, number of bond pairs is equal to number of bonded atoms. So students should know these 2 points. Now in HCF2, xenon is the central atom. How many atoms are connected to xenon? 2 atoms. So number of bond pairs is equal to 2. What is the number of lone pairs? Central atom xenon has how many valence electrons? All inert gases have 8 valence electrons. NH2 NP6. So 8 minus. Each fluorine form how many bonds? Fluorine is always monovalent, single. 2 fluorines form 2 valencies by 2.
Okay, alright.
So how many lone pairs?